Alright, you are watching this video probably because you need to know how to solve half-life problems for the first Half-Life quiz. There is an advanced Half-Life quiz we'll talk about later. But there's two ways that I like to think about solving these problems. Using a table like this or a graph like this, and if you do these enough you can kind of see them both in your head when you're doing them. But I guess before I should really get into those, I should give you a refresher definition of what half-life is. And here's the definition of what half-life is. It's the time it takes for 1/2 of some radioactive sample to decay. What does it decay into? Maybe it decays into some other radioactive element or maybe some stable element, but just this amount right here. This is good enough for this video. So let's start with the graph. The graph, we've got our x and y axes here. On the x-axis, this one is going to have time. Okay, the y-axis is going to have amount, and time. Whoever I stole this image from, I changed it a little bit, but they had this marked out in half-lives. So 1 half-life, 2 half-lives, and so on all the way across. And you can see that as the half-lives go by, the amount of the substance becomes less and less. So that's kind of like we're revisiting the definition, right? Because after 1 half-life, how much is left? If we started with 100, we're at 50 after 1 half-life. After 2 half-lives, that 50 is cut in half down to 25. So, do we have to mark this out in half-lives? The answer is no. No, we don't have to mark it out in half-lives. Let me clean this up for a second here. We could just as easily mark this out instead of counting by half-lives, we could say that we're counting by every 3 years. So 3 years, 6 years, 9 years, or this could be in seconds. So I guess for the time axis, we're going to think in any time unit we want. Seconds, minutes, billions of years maybe, or maybe we're just going to mark it out in half-lives. Either way, one key thing to remember is that time passes in a linear fashion for this quiz. What that means that as you count up, 0, 1, 2, 3, whatever, or 0, 3, 6, 9, 12, the time numbers are going to change in a linear way. So now let's talk about amount. Whoever made this video, they were thinking 100% here. So we could mark out amount in percent if we wanted to. And after 1 half-life, or 3 years, or for whatever, if that's the half-life of the substance we're talking about, you'd go down to 50%. But you don't have to use percent. We could just as easily say you had a certain number of grams of something. So maybe we started off with 75 grams of some material, and then after a certain amount of time, that 75 grams, after 1 half-life, it would be half of 75. What's that? That's 37.5 grams. So we can mark out the amount in percents, grams, pounds, whatever, or we can even say that it's in fractions. We could say that this original amount up here is 1, and then right here would be 1/2, and then here would be 1/4, and then half of that would be 1/8. So we have freedom to mess around with the units on here. And a key idea on the y-axis is that time passes in a linear fashion, and we mark out our amounts in a linear fashion. But what happens to the amount is not linear. What happens to the amount is exponential, because this is not a line. This is following an exponential kind of a function here. Not the best arrow I ever drew. So now that I've spent 4 minutes talking about this graph, let me spend a few minutes talking about this table. Here's another way to think about this graph, is to draw a table. So half-lives, here we have 0, and it counts up to 10. For my quiz, I don't think I go with any problems higher than 5 or 6. But so half-lives, I'm going to go 0, 1, 2, 3, 4. I guess I have room for 4. So time, actual real time, I'm going to have to make something up. I'm going to have to give you an element. So let's go Google one really quickly here. Okay, so let's see right here. Nice easy number. Let's say Seaborgium-266. The half-life is 30 seconds. So if I ask you a question, whoops, If I ask you a question about Seaborgium-266, the half-life is 30 seconds. So time is 0 half-lives, that'd be 0. So after 1 half-life, that would be 30 seconds, and then 60 seconds, and then 90 seconds, and then 120 seconds. And you could keep taking either of these columns down as far as you needed to. But please notice that these numbers are changing linearly. And that was what I talked about on the x-axis. Okay, so fraction, at a time of 0, nothing's happened yet. So you've still got your full amount. Maybe it's 100% or 100 grams or 30 atoms or whatever. But your fraction at the start is 1. And then after 1 half-life, you've got half as much. And then after 2 half-lives, you've got half of a half, so that's a fourth. And then half of a fourth is an eighth. Half of an eighth is a 16th. And you could keep going with that one too. So all three of these columns have something in common. I guess the whole table has something in common. I guess that's kind of a dumb comment. Oh, what did I just do? Oh my, that was a close one. I thought I lost everything. Anyway, so I guess on this side of the line, we're talking about the x-axis, and on this side of the line, we're talking about the y-axis. So percent then, if we start off saying 100, after 1 half-life, we'd be down to 50, and then 25, and then 12 and a half, and then what, 6 1/4, and you could keep going with that also. And then for a real amount, this is where I'm probably going to have to make something up for my problem, or I'll tell Moodle to make up a number. And so, like maybe just as an example, let's say our amount was 800 grams that we started off with at time 0. So after 1 half-life, we'd be down to 400 grams, and then 200 grams, and then 100 grams, and then 50 grams, and you could keep going there as well. So this is just me thinking out loud about how to look at half-life problems. Some kids, maybe you'll want to actually draw yourself a graph. You could sketch this without too much difficulty, and you can think that way. And other kids would want to draw one of these tables out for the quiz.